Today what we're going to look at in this video is the concept of an inverse function. We're going to look at what an inverse function is, how we calculate an inverse function based on an original function, and then we're going to look at the graphs of an inverse function. How do we plot them? Now, we all know what the concept of a function is. Imagine I've got two sets of numbers here. So I've got a set of numbers A and a set of numbers B. A function, f of x, is a rule which maps one element of A to an element of B. So that's our idea of our original function f of x. Something that maps an element from A to an element B. Well, what happens if I want to take this element that's in B and go back to where I was in A? I'm going to have to reverse it. I'm going to have to do the opposite of what I did. And that's where we get the idea of our inverse function. If we think about a function, as I've just said, is a rule to go from A to B. An inverse function, its aim is to reverse the effect of the original function. So it is the opposite. And that's where we need to think of a function. So imagine I gave you a function and I told you the rule to go from A to B was to times by 2 and then add 1. Well, my inverse to that would be to reverse this. So to reverse it, when I'm going the original way, I work along the way from the function. Well, when I'm reversing it, I go back the way. So in order to reverse this, my first step would be to subtract 1. Then I'd have to reverse the operation of times by 2, so I'd have to divide by 2. So we've just reversed our operations and worked back the way. That's how we calculate an inverse. And we can calculate it based on whatever form the original function takes. Now, a key thing to note, when we're noting a function, we've used the notation f of x to determine and dictate this is our function f of x. Well, the way we denote the inverse of f of x is f with a little minus 1 of x. Whenever we see this notation, what this here means is we're looking for the inverse of the function f of x. So, how do we do it? Well, it's quite straightforward really. Imagine I give you the function f of x equals x plus 1. And I want to find the inverse of this. Well, what you would do is quite simply start by replacing f of x as y. So we then write y equals x plus 1. Now I want to reverse this, so what I'm going to do is I want to swap x and y. Swapping x and y, what that does is it reverses what I'm looking for. It reverses the subject of the formula. So I now have to change the subject back to my original. What I want then is I eventually want to rearrange this so I get y equals. Well, the only thing I have to move on the y is a plus 1. To move that, I subtract it. So to make y the subject again, I simply write y equals x minus 1. And at this point, if you look, the original function f of x is equal to x plus 1, so I added 1 on to get to where I was. This function here is x minus 1, so I've subtracted 1, I've reversed it. So when we get to this point, what I can say is, well, now I know, because I've reversed it, the inverse of that function is x minus 1. So I've taken my element originally, I've added 1 to it, and that's me done the original function. I then can take my element here, invert it, so do the inverse, i.e. take away 1, and I get back to where I originally started. And this is how we calculate the inverse. This is a nice easy set of steps to do it. Imagine it's a slightly more complex function. So imagine I've got something along the lines of f of x equals 6x minus 4. Well, we can do the same set of steps and we can perform the same set of calculations in order to find the inverse of that. So again, start by replacing f of x as y. So write y equals 6x minus 4. And then swap your x and your y. So make x a subject with a direct swap. So x equals 6y minus 4. Now what I want to do is rearrange this so that eventually I can write y equals. So if I rearrange this, I can just swap both sides and write 6y minus 4 equals x. First thing I'm going to shift is the minus 4. I'm going to do that by adding 4. So I'm going to say then that 6y equals x plus 4. What I then have to get rid of is a 6. Well, it's a times 6, so to get rid of it, I have to take the x plus 4 and I have to divide it by 6. So I get x plus 4 over 6. So my original function, what I did was I times by 6 and I subtracted 4. Well, what I've done here is I divide by 6 and then I add 4. So what I've done is I've inverted it. So I can safely say now my f minus 1 equals x plus 4 over 6. So my inverse of that function is equal to that. Here's another example for you. Imagine I give you the function f of x equals 11x plus 2 divided by 3. 11x plus 2 divided by 3. And I want to find the inverse of this. Well, again, I would just stick to the same set of steps. Start by writing y equals 11x plus 2 over 3. Then, directly swap your x and your y. There's one term with each, so we just do it straight off. I could write x equals 11y plus 2 over 3. And again, I want to make y the subject. So my final line, I want y equals. So swap both sides. Got 11y plus 2 over 3 equals x. Multiply by 3 to shift that. I then get 11y plus 2 equals 3x. Next thing I have to get rid of is the plus 2. To invert it and shift it over, I take it away. So I end up with 11y equals 3x minus 2. Then my final step is to get rid of the times 11, so I divide. So I get 3x minus 2 over 11. Again, I've inverted it and done all the steps the opposite way around. First step here was divide by 3, so I've times by 3. Second step was then add 2, so I've subtracted 2. It was then multiply by 11, so I'm dividing by 11. So what I can safely say then at this point is my inverse function, f minus 1 of x, equals 3x minus 2 over 11. Now, a key bit of information. Imagine I had the function f of x equals x squared. My inverse for this, when I worked it through, would look something along the lines of f minus 1 of x equals the square root of x. However, there's an issue here. If I pick a value of x here, let's say it's negative 1, I could say that f of negative 1 equals negative 1 squared, which is 1. But imagine I picked f minus 1 of x and took that to be f of minus 1. I then get the square root of negative 1. Now, there's no real solutions to this, and we can't dip into complex numbers at the moment. So this doesn't exist. The inverse of this function doesn't exist. And a key thing to remember is that for a function to have an inverse, the original function f of x, it must be a 1-1 function. It must be a 1-to-1 function. So what that means is that every single element in A, so you can imagine we've got our two sets of numbers here, every single element in A must map to a single element in B. Alright, every single element in A must map to a single element in B. It can't go the other way. So for example, for f of x, if I pick 1 or minus 1, they both map to the same element. That can't happen. Okay, they both map to the same element, so that can't happen. It must be a 1-to-1 function for the inverse to exist. Now we mentioned at the start about the graphs of an inverse function. Okay, we mentioned at the start about the graphs of an inverse function, and there's a very, very straightforward way of doing it. So you can imagine we've got our set of axes here. So there's our y-axis and there's our x-axis. And imagine I draw some function here, f of x. So let's say it goes up that way. There's my f of x. Let's say it cuts the y-axis here at negative 2, and it cuts the x-axis here, 4. Well, if I wanted to draw the graph of f minus 1, so the inverse of it, all you have to do is imagine it as a reflection. Imagine the line y equals x going up along our graph like that. Well, to get this graph of f minus 1 of x, all we would have to do is take the graph of f of x and reflect it in the y equals x line. So our inverse function there would look something like this in this case, f minus 1 of x. And these points would switch around. So this point here is 0, negative 2. So it would switch to this point here and become negative 2, 0. This one here is 4, 0. So it switches up and becomes 0, 4. All our x and y values switch. When we're doing the graph of an inverse, that is what we have to do. We have to make sure we reflect it in the axis y equals x. when we're working with inverse functions, these are the key things we have to be able to do. We have to understand what an inverse function is, so it's just the opposite, the reversal of an original function. We have to understand how to get it, so set up your function f of x equals, put y in place of f of x, swap the x and the y as the change of subject, and then rechange the subject back to it being y equals. And then we have to understand for the graphs of the inverse, we reflect it in the axis y equal the line y equals x.